Welcome back to the Sci-Cast, the show where we discuss all things science. I'm joined by Harry, Zaynah, and the mysterious Dr. X. Today we discuss how rounding errors have cost lives, astrological transience, Déjà Vu, and a review of some of the things we've discussed in the past few episodes. I'm Max, and this is the Sci-Cast. All right, I'll kick off with a question, and just raise your hand, your actual hand, not your virtual hands, if this applies to you. Put your hand up if you've ever gotten an incorrect answer because you've rounded too early. You rounded your answer too early. Yeah, I think we can see you got your hand up there. It's fine. All right. Well, either way, we've all done it. It's really annoying, but I'm sure you'll agree it's never really been a life or death situation. At least I hope. I want you to cast your minds back to February the 25th, 1991. I think most of us weren't born, apart from Dr. X, who was probably in his 40s back then. But in a town...
I was much older.
much older. In a town called Dhahran in Saudi Arabia during the Gulf War. And positioned here is an American missile defense system, which was designed to launch a missile to sort of intercept any incoming Iraqi Scud missiles that were threatening to destroy or damage the nearby military base. Now, the clock built into this system had to multiply the sort of ticking by 1/10 or 0.1 each time to convert the time to seconds. I don't know why, but that's just the way it was. And the computer used binary. Binary is base 2. Us humans, we use base 10. We've discussed base 12. But computers just use ones and zeros, which is called binary or base 2. Now, in base 10, which is the number system we use, a 1/10 or 0.1, however you want to say it, is an innocent number. It just ends. It's not a recurring decimal. But it turns out that in binary, it actually is a recurring decimal, and I've actually got it written here. You can see that it's got lots of repeating ones and zeros, quite a headache to look at. But the problem is that the computer could only store 24 digits or 24 bits at a time. And so it would actually cut off the number here. I've drawn this red line here, hopefully you can see. And so it would discard these numbers here, and so that would produce an error. And over time, this error would add up. And after the system was running for about 100 hours, I believe, the error amounted to about 0.34 seconds. Now, you might not think that 0.34 seconds is a lot of time, but these Iraqi Scud missiles, they travel at something like 1,700 meters per second. So relatively 0.34 seconds is a lot of time. And so this meant that, unfortunately, due to the synchronization issues, when an Iraqi Scud missile was in bounds, the system failed to intercept it. It actually missed it. And sadly, that missile went on to hit the airbase and killed 28 soldiers and injured around 100 others. So, it's a very, very sad story, and my heart goes out to any of those who are affected. But I suppose the lesson is that seemingly innocent issues can have really dramatic and disastrous consequences.
Why didn't they think about that beforehand? Surely, if they'd rounded the binary number up, would that have solved the issue?
Yeah, I mean, it's I'm not sure, to be honest, why they hadn't considered it. Maybe they just hadn't realized. It's very easy for these things to just go unnoticed, I think. But yeah, when it happens, they published a report on the reason, and they sort of nailed it on the head as to why. But it seems like such a simple problem, but and yet it led to people's lives being lost. Okay, Harry. You said you're talking about astrological transience. What on earth is that?
Yeah, so it's a fun little topic that I found out only about like a few weeks ago. And more specifically, I'm going to be looking at fast blue optical transients. And what a transient is, it's an astronomical phenomenon which lasts an incredibly small duration. And I say small duration, and that's anything from seconds to several years. And you may be thinking, years, that's not really that small a duration. But in the grand scheme of things, where it takes billions of years for a galaxy to form, this is incredibly small. Um, and now, so fast blue optical transients are a type of transient which has been known to last from a few days to over a month. And it's caused by a very high energy astrophysical process. But strangely, well, I say strangely, but like a lot of things in the universe, we don't actually know what that process is yet. So that's what I find quite interesting about it. And only 4 of these events have been observed and recorded. Um, you've got the koala, CSS161010, fair few numbers in that one, the camel, and the cow. And the camel was the first of the events that was actually highlighted as an astronomical transient happening in 2018. And then the cow was observed just last year. And after looking through some records, the koala and CSS161010 were found to be similar to the events and then were also grouped into that category. But what is it exactly about these events that makes them so special? So, well, apart from them being incredibly short duration, they appear to be a star colliding with nearby gas and dust. Oh, and just to make it clear, this is an explosion. So this is a big space explosion. And so they appear to be a star colliding with nearby gas and dust. But then they get extremely bright very quickly and then fade really fast. Like I said, it's really short duration. And they appear blue in the name because of the intense heat. And while they are fading, they stay hot. So that's already really weird. So you've got an explosion, one that happens in space that only lasts like a few days. And while it fades, it's still as hot as when it exploded. And then to add to this, the explosion is 100 times brighter than any supernova. And as we know, well, like for example, stars that have died hundreds, thousands, millions of years ago, we can still see the light of them in the sky because of how long it takes for light to reach Earth. But with this, it's gone in a matter of days. And it ejects materials at almost the speed of light. So it's a massive explosion. But so these are all quite strange things. And does anyone have any ideas on how this can happen?
No. I just think it's so crazy. Like everything about astrophysics and astronomy is just crazy. I say it's like literally every time, but it's true. It's so I my answer is I have no idea. How many of these have been like observed? Did you say 4 or
Yeah.
4?
For they haven't been identical, but they've been pretty similar.
Yeah.
Obviously, this is what happens when Thanos snaps his fingers.
Obviously.
I like the references.
Although he would have to do that 4 times and well, twice almost killed him.
Yeah, that's true. Need the new theory. Do you
But
have one?
yeah, there is a theory as to what's going on, and I'd say it's could be pretty accurate because what the theory is that it's a failed supernova. So and it's when a star about 20 times the mass of the sun collapses into what would be a normal supernova, and this explains the matter being matter and materials being ejected out really quickly. But instead of it collapsing into a neutron star, it becomes unstable and collapses straight into a black hole. Hence, the light fades as it all gets sucked in. But then the problem with this is we have no clue as to what would cause the star to become so unstable while it's collapsing. and I suppose you could say that something that's collapsing is already unstable, but it should have gone into a neutron star, but it goes straight into a black hole, which is as I said, there's some astrophysical process that's going on, but we have no clue as to what it is yet.
Basically, my Thanos theory could be correct.
Very well could be indeed.
Zaynah, I feel like we've discussed this before, but tell us about your piece on Déjà Vu.
So I'm going to try and explain the mystery of déjà vu, the French phrase that literally translates to already seen. Is it a glitch in the matrix? Not quite. So do any of you know what exactly it is? And do you think it's associated with having good memory or bad memory?
Oh, I wouldn't have thought it was associated with like a specific type of memory.
Okay.
I feel like I've watched a video about this before, but I can't remember it at all.
Okay.
Maybe I'll have deja vu when you explain it.
Yeah, maybe. Max? Harry?
Yeah, go on, Harry.
I'd say it's probably good memory because, like, you know that there is something there, but you just can't remember it. Whereas if you've got really bad memory, then you won't actually remember there being something there at all in the first place.
Okay, so you're definitely onto something there. So if you're like most people, you're likely to say that it's kind of this bizarre feeling that you've experienced something that's happened before, but this answer lacks a certain je ne sais quoi. So it's not just the feeling of familiarity, but also the recognition that these feelings are incorrect, as Harry said. And it's the awareness that you're being tricked, which makes déjà vu so unique compared to other memory events. Okay, so at the start, I told you a list of some words. Max, do you remember what they were?
I can remember a couple. I feel like you said pillow.
Was one of the words which I said sleep?
Yes, I think it was.
What was it?
Okay.
I heard bed and pillow. I can't remember sleep.
Okay, so I told you a list of related words: bed, pillow, night, dream, but not the key word linking them together, which was sleep. So now usually when the person is later quizzed on the words they tend to believe that they also heard the word sleep, as you did, a false memory.
Yeah.
So to create the feeling of déjà vu, I would ask if you had heard any words beginning with the letter S, for which you would say no. And this means that when you're later asked if you've heard the word sleep, you'd be able to remember that you couldn't have, but at the same time, the word would feel familiar. And explaining how déjà vu works has been a mystery for a long time, partly because its fleeting and unpredictable nature makes it difficult to study. But this is kind of a straightforward standard technique, which is used to simulate the sensation of déjà vu so that it can be studied, for example, using fMRI scans. And the memory illusion isn't a sign of an unhealthy brain. It's almost the opposite, because basically the frontal regions of your brain are attempting to correct an inaccurate memory. And it suggests that your brain memory checking systems are working well, and that you're less likely to misremember events. So this is why it often tends to occur more in younger people and trails off in old age as memory deteriorates. Like I think I probably had it twice just the other day. And again, this doesn't necessarily mean that if you've never had déjà vu, you have bad memory, because the findings don't really reflect on people who don't experience it at all. And you might just have better memory systems in the first place, because if you're not making memory errors, then there's no triggers for the déjà vu. But yeah, it is interesting. And next time you've had that feeling where it's like, oh yeah, I've been here. Oh wait, I haven't. You can like give your brain a silent well done instead of thinking that you're going a bit mad.
And finally, to Dr. X to discuss a review of the past few episodes. I'm looking forward to this. What is it about, Dr. X?
Yeah, I just thought I would look back at the first 4 episodes we've done and look at all the questions we had and any comments that we should make after them. So, the first point I want to raise is, when we were talking about machos. Harry gave us a brilliant piece on it, and he was asking about why neutron stars are considered machos. So I did a bit of a internet search, good old Google, and I found out that eventually they become cold enough and have radiated enough energy away from them that they are too faint to be seen, and that's why they're basically classified as machos, even though you can see them emit light when they're larger. And then I got a friendly message saying that actually there are things harder than diamond. One of those things were lonsdaleite, which is an allotrope of carbon that's actually harder than diamond is. It's often called hexagonal diamond because it's got the same crystal structure, but it's hexagons instead. And that's formed when a graphite-containing meteor strikes Earth. So there we go. I got something wrong in that episode. The next question was from Harry, and he was talking about gravity versus entropy and how wouldn't gravity act against entropy? How does it work? Well, you were right. Gravity is always acts against entropy because gravity is trying to pull things closer together, whereas entropy is meant to be this idea that things want to get further away from each other as time goes on. There are a couple of theories about this. One of them is that given the universe is expanding, ultimately that sort of like kind of entropic force of expansion will cancel out with the attractive force of gravity when entropy reaches its highest, so you have zero change in entropy. Another theory is that gravity is effectively converted into entropy as time goes on, and but it's only a one-way conversion from gravity to entropy, and that's kind of the arrow of time where everything's going to get more disordered as time goes on. Finally, I want to discuss. Zaynah gave us a lovely piece on the triple point of water, and I want to discuss that. Harry decided he was going to flex and tell us a little bit about BE condensate. I wonder if he could say what it is now.
Bose-Einstein condensate.
But what is it?
Oh, I know it's to do when something's at absolute zero.
Mm-hmm.
I think it's a certain type of matter, and it's compressed at is it something like plasma compressed at absolute zero?
You're kind of close because plasma is ionized material. So effectively, absolute zero is this temperature where no particles move or have energy or anything, and what BE condensate is it's where you reduce the temperature and you compress subatomic particles to a state where they're close to absolute zero, and at that point they effectively form one quantum mechanical entity. It's like kind of like a wave where they all act as if they're just like one entity. It's kind of complicated because it involves quantum mechanics. I'm not going to get too much into it, but I thought it was really interesting. And I also found out that there has been a quintuple point found. So not it's not common. Before it was believed that there was a limit to how many different states can exist at the same time, and that's where we got the triple point of water. But there has been a quintuple point discovered before, and I feel like that sort of stuff is good for its own episode. So I'm going to leave it at that.
That's all from us today. Thank you once again to Harry, Zaynah, and the mysterious Dr. X. Be sure to like, subscribe, share, and check out our other episodes. Goodbye. Awesome.
Just setting up. Okay.
Zaynah, can I ask what you're going to talk about today, or is it a surprise?
Oh, I thought I said it. It's Déjà Vu.
Oh, you did? I forgot. Thank you.